Ladies and gentlemen, welcome back to my tutorials. We are still going on now, moving, and tonight we are presenting the KCSE 1992 Biological Sciences, Paper 2, and I'll start with the introduction. So, how are you guys? Hello, and welcome to today's biology practical session. I'm Mr. Midamo TK, a passionate biology teacher, and in this video, we will be conducting an exciting experiment on plant and animal structures. We will examine seedlings grown under different conditions, explore the life cycle of a housefly, and compare different types of feathers. This session will not only help you understand key biological concepts, but also prepare you for practical-based exam questions. So, get your lab coats ready and let's dive in. I begin by showing you the specimens of question 1. So we have the bean seedling, which is grown in the light, which was labeled as 1, and bean seedlings grown in the dark with the unilateral source of light known as S2, and those photographs were taken by me. So we have a set of potted bean seedlings grown in the light labeled as 1. The pot should contain at least 3 seedlings with 2 leaves each and cotyledons intact. A set of potted seedlings grown in the dark with unilateral source of light labeled as 2. The pot should contain at least 3 seedlings with 2 leaves and cotyledons intact. Curvature towards the source of light should be evident. So note, the 2 sets should be planted at the same time in suitable containers, e.g. tin cans, polythene tubes, bags, etc. If the seedlings are handled with care, a set can be used by several candidates. It is advisable that the teacher in charge of biological sciences, or biology for that matter, ascertain the length of time taken by the seeds to germinate and grow to the required shape and size. A ruler or means of measuring length in millimeters will be required, and so also a piece of sewing threads measuring about 30 centimeters for question 1. Question 2, you require a freshly killed, fully grown housefly larvae or maggot labeled P, and a freshly killed adult housefly labeled specimen Q. Question 3, 1 down feather labeled specimen R and 1 quill feather labeled specimen T. So the questions. You are provided with 2 sets of seedlings labeled as 1 and as 2. which have been grown the same length of time but under different environmental conditions, examine the seedlings. So from the external appearance of the seedlings, suggest with reasons the environmental conditions under which each set of seedlings was grown. So you have S1 reasons, S2 reasons. So guys, I'm going over the question. Part B, Roman 1, select 3 tallest seedlings from each set. Measure their heights and record the measurements in the table below. So you can see the seedling 1, 2, 3, height in centimeters from both sets 1 and set 2. Then down there, you get the average. So let me show you the average, where the average is. It's not very visible. Yeah, average at the bottom there. Calculate the average height for the 3 seedlings in each set. Record the averages in the table. Account for the shape of the seedlings in set S2, where you are given 3 marks. D. Giving a reason, state the type of germination exhibited by the seedlings. Type of germination, reason. For question 2, you are provided with specimens labeled P and Q. And in part A, Roman 1, you are being asked at what stage of development is specimen P in the life cycle of specimen Q. You are given 1 mark. Give reasons for your answer in A1 and above. You will get 2 marks, meaning that there are 2 reasons you are required to give. Remember, I told you in biology, when you see the marks, it suggests the points you put down. B. State 2 biological advantages of the stage of development in the life cycle of specimen Q. 2 marks again. So you need 2 points there. And C. State the environmental conditions of the habitat of specimen P. D. With the help of hundreds, examine specimen Q. How are the external features of the specimen adapted for feeding, locomotion, and last, finally, name 2 features that would be used to classify specimen Q as an insect. So, those are the specimens which were given for question 2. The larva and the fly of a housefly. A housefly scientifically is known as Musca domestica. And there I've given attribution, where I'm saying this file comes from Wellington Images and so on. You can check that one at your own time. So you have got larva of M. domestica and the Musca domestica itself. I said I won't just go in the marking without presenting the scientific classification of a housefly. So the domain is Eukaryota. Kingdom Animalia, phylum Arthropoda, order Diptera, family Musidae, tribe Musin, genus Musca, species M. domestica, and the binomial name is Musca domestica. And this one was done by Linnaeus, 1752. All right. So we have MD Caviera Walker, 1948, and MD Musca domestica. It was by Cavella Walker, 1848, and Musca domestica is by Linus, 1758. Question 3. You are provided with specimen labeled R and T. Examine the specimens. A. Identify the specimens. Identify R instead of T. Name the class of the organism from which the specimens were obtained. State two structural differences between specimen R and T. Part D is you label and draw and label specimen T. Roman 1. Roman 2, you state the function of any one part you have labeled in D1 above. So let's come to the marking or the marking scheme. In question 1, from the external appearance of the seedlings, suggest with reasons the environmental condition under which each set of seedlings was grown. S1 was exposed to light, or fully exposed to light, or light from all directions, you get a mark. Reasons, it has large green leaves, a thick, short and thick stem, a thick, upright growth or straight up growth, a thick. Reject straight alone without putting the one straight up. Any two marks. S2, it was grown in the dark, or it was grown in less light, or it was grown in little light, with unilateral light or one-sided illumination, 2 marks. The reason is that it has small pale or light green or yellow leaves or plants, or little or less chlorophyll. Number 2, it is long and it has a long and thin stem. It is short curved bed. It has a short curved bed. Note, I want etiolation for long and thin stem. So if somebody just say etiolation, you give a tick. Reject curved only if unilateral right is not given. All right. Yellowish or greenish should also be rejected because there is no color like yellowish or greenish. The color is yellow or green. Select these tallest seedlings from each set, measure their heights, record the measurements in the table below. So what we did here as examiners is that because the seeds were not of the same height, we had given allowances. And for S1, the measurements must be less than the measurements of S2. So if the measurement of seedling 1 is 3 centimeters, the measurement of S2 should be maybe 4. So if you say 4, there you tick. But if somebody says 3 and the other side you say 2, then we mark wrong. So you make sure that the measurements of S1 are less than the measurements of S2 as far as light is concerned. Average. Rounding off, averages must be supported by working. So you must show working, and for set 1, they range from 5.0 to 7.0 centimeters, and for set 2, they range from 6.0 to 8.0 centimeters. Let me show you that. Push the camera a bit behind. 5.0 to 7.0 centimeters and 6.0 to 8.0 centimeters. Question 1. Account for the shape of the seedlings in S2. Curved due to high concentration of auxins, hormone, or growth substance on the side away from the right or dark side, hence faster grown on that side than the left side, hence the curvature, or hence cell division, or hence elongation. Accept the converse. Correct hormone, e.g. IAA, clearly explain the diagram. If they decide to draw the diagram, they should explain. D. Giving a reason, state the type of germination exhibited by the seedlings. Epigil germination. Cotyledons appear above the ground, or cotyledons are brought above the ground during germination, or once to that effect. Question 2. At what stage of development is specimen P in the life cycle of specimen Q? Saliva. And you reject the word maggot. Give reasons for your answer. They are as follows: presence of hook-like structure on anterior head, lack of exoskeleton or uncutinized skin, reject decutinized instead of uncutinized, lack of jointed appendages or legs or wings or antennae, or presence of prorogues. So absent of presence of prolegs. All right. Spiracles on first segment and last segment only. Any correct 2, maximum 2 marks. Accept reasons if maggot is given for A1, but reject reason if the stage is wrong. B, question 2. 2 biological advantages of the stage of development in the life cycle of specimen Q. Lives in different habitats or feeds on different food, thus avoid competition. I think it's competition. Thus avoids, so it lives in different habitats or feeds on different food, thus avoids competition, or different ecological niches, or a stage of rapid development. You give only 2 marks. State the environmental condition of the habitat of specimen P: damp or moist or wet, warm, all right, dark and decaying organic matter or rotten matter or decayed matter, decomposing organic matter, decomposed organic matter, decomposing organic matter or decomposed organic matter. 3 marks maximum. With the end of a handlens, examine specimen Q. How are the external features of the specimen adapted for feeding? Presence of proboscis for sucking or siphoning. Presence of palps for sensing, feeding the food. Locomotion. Presence of wings for flight, movement in the air. Reduced layer wings or hauters for balancing. Presence of legs for walking. Presence of claws or pants for gripping. Locomotion, you get 3 marks. Feeding, you get 2 marks. Name 2 features that would be used to classify specimen Q as an insect. 1, it has 6 jointed legs or 3 pairs of legs. And the other one, it has 3 body parts. That is head, thorax, and abdomen. For question 3, these are the specimens. You have a down feather, a rebelled specimen R. All right. And then you have a quill feather, rebelled specimen T. And the photographs were taken by me. So identify the specimens. R is down feather. T is quill or flight feather. Name the class of the organism from which the specimens were obtained. And the class is aves. Reject the word birds. C. State 2 structural differences between specimen R and T. T has a stronger or longer or tougher or firmer or stiffer quill shaft than R. Barbs joint interlocked for a continuous vein, while barbs of R are not interlocked. T has thicker under barbs than R. And finally, T shaft is flexible than R. So that is the diagram. And these are the instructions for marking. Rebels are 11, so you divide by 2. All right. No, rebels get 1.5. You round off to 2. Have a mark for each rebel. Accuracy is a half mark. Proportionality, accuracy will involve proportionality, quill end closed, no shading. A 1 mark for shaft, radius ignored even if given. Reject radius alone. All right. I want the mark for rebel line touch one of the lines in the diagram. Okay, let me repeat. There is a point I'm going to repeat there. You are seeing the one I winding down there. I want a mark for shaft or arches ignored even if given. So arches is ignored even if given. Reject arches alone. I want to mark for rebel line if it touches one of the lines in the diagram. That is for arches. So I want to mark for every line if it touches one of the lines in the diagram. There are some rectifications I was making there. D. State the function of any one part you have labeled in D1 above. Quill or calamus is for attachment. Shaft or rachis supports the bulbs or vein. Vein provides a large airtight surface for flight. Aftershaft for insulation. Inferior ubricus to allow the feather keeping body warm. 4 marks, maximum 1 mark. That's it for today's practical session. I hope you found this lesson insightful. If you did, give this video a thumbs up, subscribe for more biology lessons, and hit the notification bell so you never miss out. Feel free to drop any questions in the comments, and I will be happy to answer them. Keep exploring the wonders of biology, and see you in the next lesson. So, we acknowledge the contribution of all those people mentioned on that slide. Goodbye and see you next time, guys.